Okay, let's go on to question 11. Now, this is a question that was quite poorly answered across the state. And it's because it's quite conceptually, it's a question that, unless you've got a good grounding in physics, might have been quite difficult to really understand. Now, Eratosthenes, of course, you'll learn about him quite early on in the HSC course. And of course, his big thing is finding the circumference of the Earth or determining it using some primary and second-hand data. So he measured, so when measuring is important, length of cast by rod in Alexandria, when it's overhead in CN, and cast no shadows. Now, what you need to do here is, there's an assumption here for him to calculate the circumference. And what we need to do is that even if you're a little bit unsure of this question, you might be able to actually tease out the answer. Now, one of the things here, let's have a look at Alexandria and CN are at different heights above sea level. Now, if you think about it, nowhere when you do discussion there is that relevant or discussed. So in terms of what we need to do here, we can probably get rid of that question there. Alexandria and Siena, same distance north of the equator. Now, one of the things you probably can remember is the fact that Africa is close to the equator, but it's not north, so we can get rid of that there. Now, the C, sun so far away that radiation reaches the Earth in parallel rays. Now, that's kind of it. That sounds good. And then we have a look at D. The measurements were taken when the shadows had minimum length. We can actually get rid of that one there because it does say there that one of them had a shadow and one didn't. So really, that's irrelevant there. So even if you were having trouble with that question, a little bit of deductive reasoning, and you can actually work that out. And of course, that is our answer. Okay, question 12. Now, this was probably the worst answered question in the paper, the one that students struggle the most with. And there's a couple of reasons for that. It's quite a conceptual thing to think about here. So P waves. And so P waves, essentially the earthquakes, the waves that first get there. But even if you didn't know that, they actually talk about here. P waves accelerate parallel to the direction in which the earthquake is moving. And so essentially what that would mean is that the P waves are kind of moving backwards and forwards. So we're going that way. And you need to sort of think about there when you're going to answer the question. And so you got to think about here, why can this cause the building to collapse? Now, when we have a look at it here, we also need to have a think about Newton's laws, because remember that's what this is all about. So if we look here, building's inertia prevents it from moving. Now, inertia is essentially one of Newton's first law. Now, if we look here, B, the building is not designed to withstand vertical forces. Now, that may be, but one of the things here, it's relating it to P waves. And as we said before, the P waves are going in that direction. Vertical, we're going up that way. So in this case here, that's actually not relevant to that information up there. So we can get rid of that one there. The building accelerates in the same direction as the earthquake wave. That may be a true statement, but it doesn't necessarily mean that that's going to cause the earthquake to collapse, because the earthquake or the building may actually be designed to do that. So we'll get rid of that one there. Sudden horizontal acceleration of building shears it from its foundations. That is probably the answer that most people thought about. But a lot of buildings are actually designed to do that there. So the reality is that in this case here, we're going to get rid of that one as well. because essentially what we're talking about here is that for this um, to work, or for what the question's asking, A is actually the main one there. Now, even if you weren't sure about all those other ones there, you could probably think about the fact that when you're talking about this concept, you are talking about Newton's laws. And so in this case here, A is the one that's the only one that's actually discussed anything about Newton's laws, which is why essentially that is the answer. Question 13 is a question that about half the candidature actually got reasonably well. It's also a question that's quite dense in its words, so it might actually take you a little bit to get through. Now let's have a look at what the main points are. So a study, we're looking at whether a new drug is effective in humans. Okay, and they searched thousands of manufacturers' databases for trials. So it's looking back at the trials that were done. So there was 1,361 trials, 3 different countries, 7 were because they were cell cultures, okay, in vitro cell cultures in a test tube, and they were comparing it to treatments currently available. And so what we're going to do here is try and relate the effectiveness of the study. And so when we have a look here, if we look at the first part there, it's well-conducted study since it used more than 1,000 trials from more than one country, providing reliable data. You know, some people would say, well, that kind of sounds all right, because we're talking about sampling size and saying there's more than 1,000 trials. But if you look up here, it's sort of talking about the fact that the 1,300 trials from the different countries, so only 7 of the trials were actually done in cell things there. Was it reliable data? Well, we actually don't, and I think that's one of the things to pick up here. Was it reliable data? We don't know anything about the trials. We don't know how they were conducted. We just know that some were in vitro, some were probably done in the field. So in that case here, we're going to put a big question mark on that one there, because it doesn't sound necessarily that it's the best answer. It's a poor study since experiments did not use random samples and were conducted in vitro, which may have differing results from in vivo in the body trials. Now, when you read that there, that actually sounds better. And what that does there is, because it's talking about comparing it, you're talking about a drug for humans, and that kind of makes us doubt this one here. So we're going to get rid of A. That sounds like actually a lot better answer, because it's talking about the fact that it's the data we're given up above talks about cell cultures, but doesn't actually talk much about what is happening in actual human studies. It's a poor study since there were no placebo studies and the experiments were conducted in 2018, so the data may no longer be up to date. Now, what we've got there, since there were no placebo studies, we actually don't know that. Now, that there we don't know. It doesn't say there weren't placebo studies, they just says there were studies done. The experiments were conducted in 1998, so the data may no longer be up to date. This exam was done in 2019. 2018 is up to date. So in that case there, we can actually get rid of this one, because that idea of it not being up to date, it's a year old. It's fine. It's a well-conducted study since the scientists used a large database of information from the manufacturers to allow meta-analysis of the data. Meta-analyses are actually a good thing to do, but all the data did come from the manufacturer. And so in that case there, we can actually get rid of this one here. And the reality is, our best answer, when you just break that all down, is going to be B, because the other ones, while there's elements of truth in what they're saying, there's also statements they're making that actually are false. Okay, let's move on to question 14. Now, what we have here, we are talking about bacteria. Okay, visible, grown on nutrient agar in a petri dish. Experiment you've probably done a million times before. Now, this one here, determine whether water purification tablets are effective in killing. And so what we have are 3 dishes. So one here, we've got sterile agar, so agar just by itself, agar with some pond water, and agar and water purification tablets dissolved in pond water. So what we have to do is establish which petri dishes we need to establish the effectiveness on water. And little bit of procedural understanding is needed here. And what we need to do is have a look at what we need to do. We need to establish some sort of causation. Now, if we look at A, it just says 3. And really, we can't actually use 1 in by itself because it's not going to talk about the effectiveness of it. So we can get rid of 3. Now, 1 and 3, if you have a look here, 1 is just a dish. There's nothing in there, absolutely nothing in there. So really, 1 and 3, we just got an agar dish by itself and then 1 with the water purification tablet. Maybe that might be used, but let's have a look at 2 and 3, which is answer C. What we've got here, we've got the nutrient agar with pond water. We've got the dish 3, which is the pond water plus the tablet. Now, when we have a look at that there, 2 and 3 is better than 1 and 2, so we're going to get rid of those because we've got changed one aspect of that. In this one here, if we put 2 and 3 together and they ended up with the same amounts of bacteria colonies, we could say that the pond water has no effect. If we compared 3 and 1, we've got 2 variables in there, and we can't just say whether it's the pond water or whether it's actually the tablet. Now, 1, 2, and 3, we're going to get rid of that one because because what the question is saying is as a minimum. Now, some studies would probably have sterile 1 there as well, just to see if there's any underlying contaminants. But the minimum we need to establish that causal relationship between the tablet and the pond water is C. It's going to be 2 or 3. Question 15 has a lot of information here, like some of the later questions. And we're talking about herbicides, herbicides designed to kill plants. And we're also talking about genetically modified cotton and the fact that there's one company that makes both of those. The GM cotton seeds, they boost crop yields, improving farmers' profits, and also increasing profits for shareholders of the company that produces both of those products. However, there is a problem with using this because the herbicide doesn't just necessarily say where it's being used. It goes into other farms, killing farmers' crops. Particularly a problem if you're a farmer next door to the GM crops and you're growing something like wheat, and this herbicide basically will destroy it. To best meet the needs of all farmers, the GM seed company and its shareholders need to enact something. Now, if we look through each of the answers here, first one, to ban the use of dicamba, which is the herbicide, that's not necessarily going to work because, as it says there, it's very effective, and one of the things that a lot of people have is that things like herbicides, new ones need to be developed because they lose their resistance, potentially lose resistance over time. Ban the use of the GM cotton crop. Now, the banning the use of this cotton crop isn't necessarily going to help anyone. So in this case here, banning the cotton crop really isn't something that we need to really think about. And let's have a look here at C. Require farmers to leave areas near their neighbours unsprayed. That's a possibility. It's logistically inconvenient, but it's something there. Require farmers to submit an application for an ethics review before they use the GM crops. Now, of course, farmers aren't necessarily the ones that need to do ethical reviews. It's the companies involved. So the reality is that one there isn't necessarily right. It's not the farmers that need to do ethical reviews. It's the companies involved in the production of these products. And this is probably why this was quite a poorly answered question across the state, because again, the idea of banning these things isn't necessarily going to work. Banning doesn't always work. And I think most people probably thought, well, you need an ethics review, because when you are talking about genetically modified crops and things like that, you usually need to take into account the ethical considerations. So that is why I can understand why people had trouble with this question, but C is going to be the best answer. Question 16. This is quite a difficult question because it requires a lot of interesting thinking here. Our setup here is we've got a 1 meter plastic ruler, okay, and it's calibrated to provide readings at 20 degrees. The lengths of these objects were measured with this plastic ruler at 20 degrees. And so we've got lengths here. We've got 10, 20, and 80. Now we've got here an experiment where they changed the temperature, and which caused the ruler to expand. The ruler being a solid, and you go all the way back to your basically year 7 theory that heat causes solid objects to expand. Now it expands in length by 10 millimeters. Now this is the ruler, and then they measured the objects again. And so what you've got to do is make a judgment on how those things will change. Now, if we have a look, we'll know that if the ruler is expanding by 10 millimeters and we measure object 1, object 1 will have a measurement that is slightly smaller, or all the objects will. Because the ruler is expanding and we assume that the objects don't, the measurement is going to be less. So the very first thing you can do is say, well, it's not going to measure the objects as being bigger. So we can automatically get rid of answers C and D, because both of those objects imply that the measurement is going to be longer. And the reality is, if this is our 10 centimeter object there, and our ruler is increased slightly, our measurement is going to be smaller. It's going to go to here. And so we can sort of say, according to that there, that we're going to get 9.9. Now, that puts us down to A and B. What we need to have a think about here is that object 2 is 20 centimeters. So on my badly drawn screen diagram, that's our 20 centimeter object. Now we need to use that ruler again. And so what we're going to have here is we're going to have a look, and that ruler, when we measure that there, it's going to be beyond. Now the key thing here is that when we're measuring it there, that slight little error here, which is 0.1, is actually going to be compounded when we measure further. So what we're going to say here is it's not just 1 millimeter here. When we measure it at 20, the 20 centimeter object, it will be a further one here. It'll have a further millimeter difference than it had earlier. When we get to object 3, which is 80 centimeters, that's going to be done by a factor of 8 as well. Effectively, what that's saying is that we can get rid of answer B, and that the answer is going to be A, because every 10 centimeters that we measure is going to be have an additional millimeter added onto it. So that is going to have plus 1 mil, that's going to have plus 2 millimeters, and that's going to have plus 8 millimeters, which effectively gives us the answer being A. Question 17, we've got a little bit of information to read through here again. We've got a sweetener called low J, uses a sugar replacement, and we've got 200 people in an experiment. And so we've got equal volumes of milk, sweetened using sugar in one and the low J in the other. And the mixtures are very equal sweetness. 250 ml cups of each were measured and put in a unique code known only to the experimenter, which is, of course, a little bit of a problem there. An assistant randomly chose 2 cups from the 500 prepared ones and gave these to each participant, and they tasted them and whether they tasted the same or not. The assistant recorded the response as well as the code in each cup. Okay, so the purpose is to determine something, and so we're going to get that out of there. The one thing here, the experimenter who's controlling it, they knew what they were doing, but we can also sort of say that the assistant doing the actual testing was sort of an effective double-blind trial for this here, so that's pretty good there. The purpose of the experiment was to determine the following. People were likely to be influenced by the placebo. Now, what we've got here, you say, well, that's a possibility. However, they were both given the 2 cups and the assistant had no idea. So the assistant didn't know which one was the placebo and which one was the non-placebo. So in that case here, people couldn't be influenced by whether there was a placebo or not. So in this case here, we can get rid of A. People's ability to identify the taste of low J was related to their ages. We don't know that. Ages were random, so their age wasn't something that was being looked at in this study. So we can effectively get rid of B as being an answer as well. People could taste the difference between the 2 samples they were given. Now that sounds plausible. And if we look here, each participant was given 2 of the cups. One had this low J, one had the sugar. So C is a plausible answer for us. People could identify the samples that had been sweetened by using low J rather than the sugar. Now again, that's kind of, well, maybe they could, but they weren't really told that. They were just given 2 samples and asked whether they could taste the same or not. All they were asked to do was taste whether they tasted the same. So in this case here, it's not about identifying them because they had no idea. They had no idea that there was an artificial sweetener or even sugar in the cups. So in this case here, what that breaks it down to is that really from the information we're given, the experiment was just asking simply, was there a difference between the 2 samples? Now again, this is question 17, so it is designed to be a little bit harder, and students did actually had a bit of trouble doing that. But it's just basic scientific practice that you just determining between 1 or 2 variables. Question 18, a lot of information there, but students seem to actually engage with this question quite well. So if we have a look, we've got someone conducting an investigation about which of the scientists has a greater impact in their field of research. And so 4 unnamed scientists there, number of years they've been doing research, the number of peer-reviewed papers, the number of citations, and this thing here, the number of papers with at least 10 citations. And so what we've got to do there is have a little bit of a look at the different things here. And one of the things, the number of years conducting research. People could argue that maybe that's important. Number of peer-reviewed papers. Considering we talk so much about that, that's probably a pretty good indicator. Number of citations is probably a good, and as well as this paper IA10 index, which is the number of times those papers have been cited a huge number of times. So what we need to do is, one thing we can look at here, the number of citations is reasonably about the same. They've all had the total number of citations. We can also look here at the number of peer-reviewed papers here. And one thing there, we look here that 1, 2, and 3 have about the same, or 1, 2, and 4, sorry. 4 has slightly more, but scientist 4 has also been working for 40 odd years compared to 8 and 9 for scientist 1. Also, scientist 4, their paper's only been done 26 times, scientist 3 42, and scientist 1 53. One of the things here, if we have just a look here, the one with the most impact is most likely going to be scientist 2, because even though they've only been working for 9 years compared to scientist 3 and 4, they've had a lot of peer review, they've had a lot of citations, but their papers have been, 75 of their papers have been peer cited more than 10 times. So in just looking at this data here, scientist 2 has the most impact. So let's have a look here. Scientist 1's published about 19 papers per year, but it's only been in research for 8 years. So this scientist research must be fairly basic and must be having the least impact. When you have a look at that there, that scientist, even though they've been only working for 8 years, has had just as much impact as scientist 4, and even more impact than scientist 3. So the idea that this, just the years, doesn't really make sense. So we're going to get rid of A, because that really, they've had a massive impact. Scientist 2 has published approximately 19 papers per year. That's pretty much clear. Has the highest I-10 index and nearly the highest number of citations. So this scientist's research must be having the greatest impact. That sounds pretty plausible, so we're going to keep that in mind. Scientist 3 has only published approximately 4 papers per year, which is the lowest number of this papers per year. So this scientist must be having the least impact. That's probably true, but that's not really what we're after here. We are eventually going to ask who has the most impact. So in that case there, we're going to actually cross that one out, because that's not really, while it may be a fact, it's not relating back to our original idea for the question. Science 4 has only published approximately 4 papers per year, but has had both the highest number of papers and the highest number of citations. So this scientist's research must be having the greatest impact. That may be true, but if we do look at the I-10 index, they've published the most amount of papers, they've had the most number of citations, but only 26 of the papers have more than 10 citations. So really, you could argue that they've probably, and their I-10 is the least of all the 4 of them, they've probably had the least impact. So we're going to get rid of that, and we're going to say that basically our inference here, and it's the inference that relates back to what our initial question is about who's had the most impact, is going to be scientist 2. Okay, question 19. A question that wasn't really answered that well across the state. Only a third of the students really were able to engage with this question quite well. And so we do have a lot of information here. We're talking about an app on a smartphone, producing a spectrogram, essentially just an image of the sound, and shows the frequency present in sound and how these vary over time. Now, figure 1 there, which shows us a sound of a fixed frequency. So you've got 900 hertz here, and it shows that it's just constant. The same source of sounds result in figure 2 when shown moving relative. So, which is what we have here. So essentially the question's telling us that these two images are showing the same sound. The difference is that in the second one, when it's either the smartphone or the sound is moving, and it produces this slight variation in the frequency. And so what we need to do is have a look here at which statement describes the movement of sound, which of these is consistent with the results shown in figure 2. Now essentially what we are doing in this question is relating back to the Doppler effect. Again, this might be a question that physicists, students doing physics, are going to have a slight advantage in. And so let's have a look here. The sound source is moving directly towards the smartphone and the sound has increased in loudness. Now, because we are talking about the Doppler effect, this idea of loudness is talking about the amplitude. And some students might actually get a bit confused there because we're usually talking about the amplitude of the sound intensity. In this case here, we're actually talking about frequency. So answer A is wrong because it's giving us a completely incorrect statement. B, the sound source is moving directly away from the smartphone and the sound has increased in frequency. Now, based on what I just said there, that kind of almost sounds plausible, except if you look here, it does increase the frequency, but then the frequency decreases. So B can't be entirely correct because it's only giving us an idea of what's happening in half of that there. So we're going to get rid of that there. C, sound source is moving directly away from the smartphone and it is oscillating along a line perpendicular to this motion. So if we have a look at that there, that almost sounds plausible. Moving directly away from and is oscillating along a line perpendicular. That kind of sounds plausible. So we'll just give that a little bit of a tick there. D, sound source is moving directly towards the smartphone and it is rotating in a vertical circular path which has a plane parallel to the direction of the motion. Now, a lot of info there, and that's all pretty plausible. And what we've got to do is try and ascertain between the two of these here. Now, what we have is that C, moving directly towards the smartphone, oscillating along a line perpendicular to this. That would probably have quite a sharper thing to what we've already got there. The reality is that the answer is going to be D because it is moving directly towards a smartphone. It's rotating in a vertical circular path, which is a plane parallel to the direction of the motion. And so the reality is that D is going to be the better answer in this case. Okay, question 20 is another difficult question, which is what you would expect from the last question in this paper. And we're having a look here at an experiment where you take a sample of gas and use a sealed syringe and sort of model what's going to happen with the pressure and the volume. This is essentially just an experiment to confirm Boyle's law. You've got a pressure sensor there which measures the pressure, which is what we've got there in the graph, and the volume is going to be measured. So we can see that here, these graphs here all have pressure volume, except for these two over here, which have pressure over the inverse of the volume. Which graph is consistent with the student's hypothesis that pressure times volume over gas is a constant? Now, this is an important little part here with the constant part here. Now, before we even go back and explore that, we'll just have a look at which ones are blatantly wrong. So if we have a look here, pressure and volume. So it's saying here that as pressure increases, volume increases, which is complete garbage. We look at B, pressure over 1 of the volume. Okay, now this one here, the interesting part here is the fact that we've got 1 over the volume. And so what that's saying is that if you increase pressure, 1 over the volume increases, which is implying that it does decrease. So that's one we'll keep in mind there. Let's go down to C, pressure and volume. Now, at first glance, this looks like a really plausible answer, and I think this is where most people sort of made a bit of a mistake here. And it's also this idea that you've got to have a look here. Pressure times volume of a gas is a constant. So we are trying to find that there. However, when you measure it this way, it actually becomes a curve. It's sort of like an asymptotic curve. So in this case here, it's not going to be a straight line. It's going to be a sort of hyperbolic line going down there. So in this case here, we've got to say that that's actually wrong. Now, if we go here to D, pressure over inverse of the volume, that's a very similar graphical shape to that one there. So that's kind of wrong as well. Now, just a little bit of deductive reasoning there has got us out of that B is really the only correct answer. And this is a really hard concept to get in your head because it's possible that a lot of people actually haven't sort of graphed it in that sort of way. Now, what we can do is to actually show this. This is a little sample I prepared earlier. This is just some data, and in this case here, most of the examples that use this, they talk about mass in your experiment, which is what's going to put the pressure down there. But you can just as easily change that to pressure as well if you want. That's just the example I was using before. And so when we change that there, and all you do here is volume versus pressure here, this is what happens when you change the mass or you change the pressure. What happens, you get that asymptotic curve all the way down here. But of course, maths and science not being really usual here, if we do 1 over the volume versus mass, and I know that these things here are kind of inverted, but you still get here that you actually get a straight line going up there. And so when you graph the inverse volume versus mass, you get essentially a straight line, which is kind of a little bit different to when you don't have the inverse there. So in that case there, what we have is a case where, this being quite a difficult question, and we'll get rid of that, is that we actually will get a change in that there. So when we go back and have a look at our question here, we can get rid of those ones there, but in the end, the answer is going to be B.